Write atomic symbols for some isotopes with kind of a scant bit of information given to us. Now, the atomic symbol is a hieroglyphic that is used to describe to the reader the charge, the number of protons, number of neutrons, and things like that. It's very similar to the hieroglyphic you may see drawn at the top of a map. If you were looking at a map, say just a map, a road map, and you saw an arrow like this pointed up or to the left or right, it's understood that that's the north. And if you were to look or be driving in the other direction, you're going the other direction of north. And it's just up to the reader to know that. This is how we treat atomic symbols. So let's kind of draw a hieroglyphic in the code for atomic symbols right here. Now in the center of this, I'm just going to put a big question mark. And that question mark is meant to represent like the letters that were common with the periodic table, like C for carbon, H for hydrogen. I just don't want to put an X because I just don't like X's, but big letter in the middle right there. The number in the bottom right-hand corner refers to the quantity. So for example, water has a formula H2O. How many hydrogens are in water? You know that from the baby number in the bottom right-hand corner. Number in the upper right-hand corner refers to the charge. Now the charge is a combination, a little arithmetic, with the number of protons and electrons that are present in the atom or the molecule. If there are more protons than electrons, it'll have a positive charge. If there are more electrons than protons, it'll have a negative charge. And that's true with everything in the universe. Anything in the universe that has a positive charge has lost electrons. Anything in the universe that has gained electrons has a negative charge, even like the clouds in the sky when it comes to lightning bolts. In the upper left-hand corner is the mass number. Mass number, that math is real simple. It is the protons plus the neutrons. Note it is always a whole number. These are always whole numbers for Gen Chem purposes. If you get to OChem or upper levels chemistry, you can see fractions or decimals here. But in Gen Chem, these are whole numbers, the charge, the quantity, the mass number. And down here in the bottom right-hand corner, we have the atomic number, which is a vague description that literally just means the number of protons. This is rarely seen because the big letter in the center is also the number of protons. For example, carbon is defined. Carbon is what man calls Mother Nature's creation that contains 6 protons. Mother Nature made thousands of atoms, hundreds of different types of atoms, I'm sure. And the ones that have 6 protons in the nucleus, we call carbon, abbreviated with the letter C. Here are some examples of some scant information given to us, and we're going to write out the atomic symbol for 2 examples here. We have 11 protons, a mass number of 23, and it is a neutral atom. This is enough information to fill out an entire thing here. Okay? 11 protons. That's easy. That's a gimme right there. It's the number in the bottom left-hand corner. Now, Mother Nature makes atoms with 11 protons. We call them sodium atoms, just by finding that on the periodic table. So that is a big Na in the middle here. That's a gimme, a 2 for 1. We are just told the mass number. Bingo. Now, we are told it is a neutral atom with a 0 charge. This is just like getting handed down to us here. The quantity, for this example, we're just talking about 1 atom here. Probably not going to find that in an answer key, but just being complete here. Letter B. 75 neutrons, 54 electrons, a +1 charge. Whew. Let's work this out here. Well, the charge is the gimme one. So I'm going to put that in right there. +1. That's the charge that's given to us right there. Now, the number of electrons and the charge. We are told it has a +1 charge. So that means it has more protons than electrons. Anything that has a plus charge has more protons than electrons. How many more protons? That many more. So 55 protons must be our atomic number to have a +1 charge with only 54 electrons. If I have 55 protons, that is cesium. Just finding that on our periodic table here. Now, quantity, put that 1 in there just to finish that off. Right up here. This is the mass number, the protons plus the neutrons. 75 neutrons plus the 55 protons. That is going to be 80 plus 50. I think that's going to be 130 is the mass number. So that is our final answer for letter B. I hope this helps. Thank you.